Greetings, ladies and gentlemen. Today video I'm going to answer question number 13. A piston cylinder device initially contains 50 liters of liquid water at 25 degrees C and 300 kPa. Heat is added to the water at constant pressure and the entire liquid will vaporize. So we have a piston cylinder device that considered as closed system. So there is no mass in and out of the control volume for the entire process. At the initial condition, we have a water that were in 15 liter in volume, 25 degrees C in temperature and 300 kPa in pressure. After some time, the pressure with the constant pressure, the volume and the temperature will be a difference. So been asking what is the mass of the water, we can define the mass by density equation. Because the density have a unit of kg per meter cube, if somehow we can cancel out the meter cube, we can get the mass. Been given at the initial condition 15 liter, we can cancel out the value of meter cube by convert the value of liter into meter cube. 1 meter cube equal to 1 K liter, so we need to 15 liter over by 1 K liter, so you will leave out only meter cube right there. So you multiply it by its density, you can cancel out the meter cube, so you will get 49.85 kg. So that is the mass for water in initial condition and also in the final condition. Because the system were enclosed, there is no mass in and out of the control volume, the mass were conserved. B asking what is the final temperature. We can define final temperature by the table, but the question is what is the table that we need to refer. We know that at the final condition, the water were in vapor at 300 kPa because the pressure were constant. So we can define the temperature by refer to saturated pressure table A5. At 300 kPa, the value of T saturated will be 133.52 degrees C. And yes, indeed, it is an answer. So we'll have the temperature, final temperature at 133.52 degrees C. Question C asking what is the total enthalpy change for the entire system. Before we begin with the calculation, we need to define the graph, PV graph. So at the first condition, the pressure will be in 300 kPa, and at the final condition, the pressure also in 300 kPa. So there is the graph, PV graph, but the volume that will be different because logically when you heat up the water and logically the volume will be increased. So that's why volume at the final condition or condition 2 will be bigger than condition 1. So difference in enthalpy is equal to H2 minus by H1. We can define H2 by the same table A5, which we define the temperature, final temperature. In the same row, we go to the enthalpy. But in here, we have 3 options for knowing the value of enthalpy, HF, HFG, HG. Since that at the final condition, the water in vapor, aka in gas, so that's why we refer to HG column. That will bring into 2724.9 in the form of kilojoule per kg. HF, it is referred to enthalpy in the form of liquid. HFG, it is just as simple as difference between HG and HF. But anyway, we'll have H2 will be 2724.9 kilojoule per kg. Now, what is the value of H1? Value of H1, we can define also in the thermodynamic table. But first, we need to know the condition of the water at the initial. So at the initial, the water were in 300 kPa at 25 degrees C. If we go to saturated table that focus on the pressure, which is table A5 at 300 kPa, the temperature that will be 133.52, but the temperature that we were dealing at the initial will be 25 degrees C. So it means the water were in compressed liquid. So we need to refer to compressed liquid table. But unfortunately, at this table, the lowest value will be 5 megapascal. If we convert 300 kPa into megapascal, we will get 0.3 megapascal, which is doesn't state at this table. Now, doesn't need to be freaked out. We can define the value by refer to saturated water temperature table. Why so? Why so? It is because this table consists approximately the same specification of water as compressed liquid. So, with 25 degrees C, we can define the value of enthalpy at the initial condition. Just simply go to 25 row, refer to enthalpy area. You will have HF, HFG, and HG. We need to take the value of HF because the water will be in compressed liquid. So it is just logic to say we need to refer to HF. So at the initial condition, enthalpy were in 104.83 in the form of kilojoule per kg. So the difference between enthalpy that will be H2 minus by H1 equal to 2620.07 in the form of kilojoule per kg. But question asking the enthalpy change, not specific enthalpy. So we need to cancel out the value of kg right there by multiplying the change in specific enthalpy upon the mass. Thus, we will get 130.61 megajoule. So that is the change in enthalpy. The question D asking show the process of the TV diagram with respect to saturated line. So this is the TV diagram. We have a graph like a hill. It is referred to saturated line. And this condition final the initial position at 25 degrees C, and the final condition will be at 133.52 degrees C. So I think that's all for today. Thank you for watching and have a nice day. Bye bye.